you have my
Yes,
voice now?
yes, Doctor, it's clear.
Okay, okay, thanks. Okay, let's continue this example. As I said, in this example, we want to compute the probability of that a person has the disease given that the test result is positive. It means that we want to compute the probability of A given B. Any question? Okay, please pay attention that in this example, we have the formula. So the probability of A given B is equal to probability of B given A times probability of A divided by probability of B. Okay, any question? Now we replace the values. Probability of B given A, we have this probability here. So probability of B given A is equal to this value. Probability of A, as we said in in this section, probability of A is equal to this value. But divided by probability of B. What's the probability of B? For computing probability of B, we now have the probability of B given A, and also we have the probability of B given A bar. Do you have my voice?
Yes,
Okay.
Doctor, yes. We have your voice. Please, if you can return to enjoy to us on
Yes,
Google
yes,
Meeting.
yes. I forget with this system to enter. Probably we have the probability of B given A and probability of B given A bar. But we need the probability of B without any condition. We compute the probability of B in the previous example. So we use the probability of B that we compute in the previous example, this formula, in the denominator of this fraction. So we have this formula for the computation of probability of A given B. In this example, as I said, we use the Bayes theorem. Any question? No question. Let's go ahead. Okay. But what's the next subject of this session? In this slide, as you can see, we want to speak about random variables. What is a random variables? Previously, we speak about random experiments, sample space, events, probability of events, characteristics of probability, Bayes theorem, total probability theorem, and so on. Now, in this slide, we want to talk about random variables. What is a random variable? Suppose omega is our sample space. Omega 1, omega 2, omega n are some events in this sample space. A random variable, please pay attention that a random variable is a function from sample space to the real value line. It means that in random variable, we assign a real value to every outcome of a random experiment. For example, if we toss a coin, Or sample space in tossing a coin is head and tail, is this set, head and tail. Okay, if we assign to head the value of 0, for example, and we assign to tails the value of 1, then we have a random variable, we call it x, that takes the values of 0 and 1. X is a random variable. A random variable is a function of or sample space to the real value line. In other words, in a random variable, we assign a real value to every outcome of a sample space. Okay, here x that takes the values of 0 and 1 is our random variable. Another example, uh, suppose that we toss two coins, toss two coins. When we toss two coins, our sample space is like this. Head, head. It means that the first coin is head and the second coin is head too. Head, tail, tails, heads, and tail, tails. Okay, in this example, in this random example, our sample space have four members. If we assign real numbers to each outcome of a random experiment or to each member of our sample space, we have a random variable. For example, we assign to HH value 1. We assign 2 to HT. We assign 3 to TH, and we assign 4 to TT. Now, we have a random variable that takes the values 1, 2, 3, and 4. These random variables take the values 1, 2, 3, and 4. This is a, x is a random variable. So again, I repeat that the random variable is a function from sample space to real value line, or in other words, to have a random variable, we should assign a value, a real value to every outcome of our random experiment. Okay. But you should pay attention that the random variables may be discrete or may be continuous. You should differentiate in your mind between two types of random variables, discrete random variables and continuous random variables. It is clear that discrete random variables takes discrete values and continuous random variables takes continuous values. For example, in tossing a coin, or random variable is x, x takes the values of 0 and 1. So this random variable that defined in this slide is discrete or continuous. Can you say in this slide x is continuous or uh, discrete?
Discrete, doctor.
Yes. Here x is a discrete random variable. In the next example, in tossing two coins, we have this random variable x, that takes the values 1, 2, 4. This random variable x is continuous or discrete?
Also discrete.
Yes, it's discrete too. But what's the example of continuous random variable? Suppose that we have a line segment, from 0 to L. Okay, we have a line segment from 0 to L. We place a point in this line. We place a point For example, a blue point in this line. This point may be here, or the point may be here, or the point may be here. The point may be here. The place of the point in this line segment is a random variable. Okay, is this random variable, if we call this random variable x, or random variable, determine the place of this blue point in this red line, in this red line segment. Okay, x, that is our variable, is continuous or discrete?
If it is
Yes.
continuous, it will be uh, not discrete.
Yes, yes.
It's
X,
continuous.
yes, x is in the interval of 0 to L, so x is continuous. Here we have a continuous random variable. In this example, we have a discrete random variable. In this example, we have a discrete random variable, but here we have a continuous random variable. Or assume the value t specifies the duration of a phone call. We have a phone call, duration of a phone call. Suppose that t may be in the interval of 0 to t, duration of a phone call. Duration of a phone call. T is a random variable. That means the duration of a phone call. And it may be in the interval between 0 and t. Here, t is a random variable. Is it continuous or discrete?
Continuous.
Yes. Again, t is continuous random variable. Okay. Any question about continuous or discrete random variables?
Yes, doctor.
Okay.
The continuous, we can explode the t as a curve and the variable under the curve of t. That's mean,
Pay attention, please pay attention that in this example, t may be a value in this interval, but we don't know.
Okay, that's mean.
Okay,
I confused for
okay,
this.
okay. Here. Okay, it's very important that you pay attention that a random variable is discrete or continuous, because the analysis of discrete random variables and continuous random variables are different from each other. Okay, any question? Let's go ahead. Now, we want to fully understand the random variable. We want to fully understand and fully analyze a random variable. What we need to fully understand a random variable? We should pay attention that we are faced with a continuous random variable or with a discrete random variable. If we encounter with a discrete random variable, if we have a discrete random variable, to fully understand the discrete random variable, it's enough to know the PMF of this random variable, probability mass function, or in brief, PMF of this random variable. So for a discrete random variable, knowing the PMF of this random variable or probability mass function of a discrete random variable is enough for us to fully understand the discrete random variable. But what's the meaning of PMF of the random variable? How we define the probability mass function for a discrete random variable? For a discrete random variable, we use this notation for PMF. And PMF at every point, for example, suppose that we have a discrete random variable x. We have the discrete random variable x. X takes the values x1, x2, and so on. PMF of this discrete random variable specifies for us that this random variables takes x1 value with the probability of p1, x2 value with the probability of p2, and so on. So, having the PMF of a discrete random variable, we have the probability of different values of this discrete random variable. Okay? As you can see in this plot, in this example, we have a random variable x. X takes the values 0, 1, 2, and 3. What are these bars? It means that it's the PMF of this random variable, and it means that this random variable x takes the value 0 with the probability of 1/8. This random variable x takes the value, for example, 2 with the probability 3/8. And this random variable x takes the values 3 with the probability 1/8. Okay, this is the meaning of PMF. PMF very simply specifies for us the probability of different values of a discrete random variables. Any question? Is my voice clear? Okay. Again, back to this example. This example, tossing a coin. Our random variable is this. X takes the value 0 and 1. Okay, if we have a fair coin, it means that the probability of heads and probability of tails are same, are equal to each other. Fair coin means the coin that the probability that we have tail and we have tail and heads are equal to each other. So what's the PMF of these random variables? Okay, this random variable take the values 0 and 1. Now, what is the probability of that this random variable takes the value 0? Can you say?
1, 2, 1 over 2?
Yes, 1/2.
1/2.
And what's the probability of this random variable takes 1?
It's equal to the...
Yes, it's equal. Okay. Any question? Other example. In this example, tossing 2 coins, we have this random variable x that takes this value. So if we want the PMF, we should plot such plot. Okay, again, suppose that we have 2 fair coins. Probability of head and probability of tails is equal to each other for 2 coins. Can you say what's the PMF at 1?
Quarter, Doctor. 1 over 4.
Okay, yes, yes.
For all of them.
Yes, exactly. Thanks. Okay, any question? So it's clear that the summation of the values of PMF should be 1. should be equal to 1 because our random variable takes the values 1, 2, 3, or 4. And if we sum the probability of different values, it's equal to 1. Okay, any question? Okay, in this example, suppose that we ask you to compute the probability of this event. Probability that the random variable x is greater or equal to 2. We use the PMF to compute this probability. Can you say me what's this probability? How we can compute this probability using this PMF? We want to compute the probability that random variable x, that its PMF is like this, is greater or equal to 2. How we can compute it?
We have two probability, Doctor. 3 over 8 and 1 over 8.
Okay, thanks. Very good. Probability that x is greater or equal to 2. It's the probability of x is equal to 2 plus probability x is equal to 3. And from PMF, we have these values. Okay? If we have the PMF of random variable, we fully understand that random variable. But again, pay attention that we can define PMF for discrete random variables. Okay? Any question? Let's go ahead. It's very important to pay attention that we cannot define PMF probability mass functions for continuous random variables. Why? Because when we are faced with a continuous random variable, when we have a continuous random variable, the probability that a continuous random variable is equal to the specific value is 0. Okay? Here we have a continuous random variable that takes the values in this interval. Here, if we write this probability that x, for example, random variable x is equal to a specific value, for example, x0. Suppose that x0 is here. X0 is here.
Class.
The probability that a continuous random variable is exactly equal to the specific value is 0 because it's continuous.
Thank you.
Okay?
Doctor,
We have
do you hear me,
infinity
please?
numbers that are continuous in the intervals between
I'm Mariam
0 and L.
Mazlagani, Associate
So the
Professor of
probability that our random variable
Artificial
is equal
Intelligence
to the
Group in
specific number
Department of
in
Computer
this interval
Engineering
is
of
equal to
Americaba
0
University of
because we have
Technology. In this
infinity
part, we focus
numbers
on
of points
probability
in
and
this
random
interval.
variables, and
They're
we expect that
continuous.
you will be more
Okay?
familiar with these concepts, probability, random variables, statistical analysis at the
Okay,
end of
so
this part of engineering mathematics course. But
we
what's the
can't
content? You have my pointer.
we defined cumulative distribution
Yes,
function or
it's clear.
CDF for
Okay.
continuous random variables and also for discrete random
Then we
variables.
discuss about some
We can
important
define
PDF probability
CDF
density
or
functions. Then
cumulative is less or equal than the value of x. Okay, so the CDF at every point specify for us the probability that our random variable is less than this value or equal to this value. Okay, CDF at every point the value of CDF at every point specifies this probability at this point. Okay, suppose that we have a random variable x that takes the values 1 and 0, 1 with the probability of P and 0 with the probability of Q. Here, we have the CDF function of these discrete random variables. But why the CDF is in this form? Please pay attention. CDF function for negative values is equal to 0.
Yeah.
Why? Because the random variables or random variables takes the values 0 and 1, and it doesn't take negative values. For example, suppose we want to compute CDF values at this point. CDF at this point. It means that through this formulation, it's equal to the probability that our random variable is less or equal to -1. Okay, our random variable take the values 0 and 1 with the probability of Q and P. Probability that our random variable is less than or equal to -1 is equal to what? What I should write here? Q is the probability that our random variable takes the value 0. But now here, we want the probability that our random variable is less than -1. It's 0, yes. It's equal to 0. Why? Because never our random variable takes the values less than -1, because our random variable takes the values 0 and 1. And these values are not less than -1. Okay. So for other negative values, we can compute the CDF like this, and the CDF is 0 in this part. But why the CDF is equal to Q in this interval? Suppose a point in this interval, for example, 0.4. We want to compute the CDF at this point, 0.4. Okay, we have this. We want to compute CDF at this point. It means probability that the random variable x is less than or equal to this value. Okay, what's the probability that our random variable is less or equal to this value? As we can see here, our random variable takes the value 0 and 1. So this probability means that it's equal to probability that x is equal to 0. Okay, because x is 0, x takes the value 0 and 1. If x takes 1, then it's not less than this value, 0.4. So it's equal to the probability that x is equal to 0 and it's equal to Q. For all of the points in this interval, in the interval between 0 and 1, the CDF function is equal and it's equal to Q. Okay? Any question? But why? The CDF value at...
Doctor,
Okay.
please, can you repeat?
Yes. As I said, we see that the CDF function in this interval between 0 and 1 is equal to Q. We want to compute this value, and we want to understand why the CDF in this interval is equal to Q, okay? So we select a point at random. Randomly, we choose this point 0.4. And we want to compute the CDF at this point. Okay, I wrote a CDF function at this point, and according to the definition of CDF function, it's equal to this probability. The probability that a random variable is equal than this value or less than this value. Okay, pay attention that a random variable takes the value 0 and 1. 0 with the probability of Q and takes 1 with the probability of P. Now we want to compute the probability that a random variable is less than 0.1.4. Okay, or random variable takes value 0 and 1. If the or random variable takes 0 value, it's less than this value, and it's okay for us. But if a random variable takes 1 value, it's not less than this value 0.4. So this probability is equal to the probability that a random variable is equal to 0. And we know that the probability that our random variable takes the 0 value is equal to Q. So CDF function at this point is equal to Q. Okay? Oh, and finally, the CDF function in this interval, greater the numbers that are greater, the values that are greater than 1 is equal to 1. Why? We want to compute the CDF function in this interval. For example, we select value 2 in this interval, and we want to compute the CDF functions at 2. According to the definition of CDF function at point 2 means probability that a random variable is less than or equal to 2. Okay? Or random variable takes the values 0 and 1, and all of these values are less than 2. So this probability is equal to 1. It means that a random variable x is certainly less than 2. And it's clear from the definition of this random variable, because the values that this random variable takes are 0 and 1. So certainly this random variable is less than or equal to 2. Okay? Any question? Let's go ahead. Now, in this slide, we have another example. We have a random variable x that its PMF is such, this is like this. What is its CDF? Its CDF is such this. Okay? You can simply compute the CDF at different point, similar in this way that I explained for you in this example. For example, you select the negative value, you select the value in this interval, you select the value in this interval, and you can continue to obtain these CDF functions completely. If you have any question, please ask me. Okay. I think it's enough for today, but review the today's subject. First of all, we talk about examples. First examples using total probability theorem, and in the next example, we use the Bayes theorem. And then we talk about random variables. We focus on discrete random variables and continuous random variables. And we said that you should pay attention to the differences between discrete random variables and continuous random variables. Then we said that to fully understand the discrete random variables, it's enough to have its PMF, probability mass function. Probability mass function is a simple function that defines and specifies for us the probability of different values of the random variables. But we can't define PMF for continuous random variables, because for continuous random variables, the probability that a continuous random variable is equal to the specific value is 0. So we should define another function. We defined a CDF function and you can see the formula of CDF function in these slides. And we discuss about 2 examples. Okay, any question? No question. Okay. Okay.
Okay, doctor.
The remaining subjects for the next sessions, inshallah.
Inshallah.
Inshallah, doctor. Thank you so much, doctor. Thank you.
Thank
For more examples,
Do you hear me?
You are now unmuted.
for more examples, you can use this reference.
Doctor, do you hear me, please?
Yes, yes.
Doctor, okay, no problem. On this slide, please, which book we depend on? Please, which book from these 2 books?
I suggest you to focus on this book. Okay, theory and problems of probability, random variables, and random process, because these books contains many solved examples. Okay. First of all, I suggest you to focus on the slides and my explanations. Okay. First of all, focus on the slides and my explanations, the proofs that we have in the class. And next, for the next step, you use this book, this reference, because it contains many solved examples. Okay. First of all, you focus on the slides and the subjects of the class, and in the next step, you should use this reference to have many more solved examples. Okay.
Yes, doctor.
Doctor, if possible, doctor, if possible, selected, if you can, select some exercise, important exercise in this book to focus of them, to solve it. Please, doctor.
All of
If you can.
all of the examples of this book is good for you. Okay. The examples are not difficult, and we expect that you can solve the examples. But I see this book again, and if some examples are more important, I mention for you and select for you.
Doctor, depend on only example. We don't care about accessories in this book.
As I said, first of all, you should focus on slides. Okay. You should focus on the subjects that I explained for you in the class. For example, what's the total probability theorem? What's the proof of this equation, what's the Bayes theorem, what's the proof of this equation. First of all, the most important part of your session is these subjects. Okay, in the next step, if you want to solve some problems, you can refer to this book. Okay, but it's
Okay,
more
Doctor.
important for you the subjects of the slides. Please repeat.
Doctor, please, can you give us some activity to all students to do it, and we get some marks if
No,
you can?
our time is very limited, and we want to
Because
justify.
because the time we don't have enough time, and we have only in engineering math three book, one book for linear algebra, and two book for probability, and we have also algorithm.
Mm. Uh,
algorithm we
Again, I
don't have
repeat
enough
that
time. All these book, doctor, on 1 month. We
no,
can't we can't study this on 1 month.
no. It's not correct. You don't need to read this book, the first
Okay,
reference. The material of a slide from this book, but it's not need that you refer to this book because it's complicated. It's a bit hard for you to read this book. It's just enough to focus on the slides. And the slides are a small part of this book. Okay, if we want to study, to teach you all of these books, we have 2 terms. Okay, we need 2 terms, but the time is limited, and we cover very compact sections of these books. You don't have 4 books for a study for the exam. We only cover some subject of these books, and the subjects are from our BSc courses. At the first or second semester of our BSc schedule, the students pass this course. So it's essential for you to be familiar with these subjects. We expect that you will be familiar with these subjects because they are not complicated. They are elementary subjects in statistics and probability. Okay,
okay,
the
doctor.
students
If
in
you
our BSc program passes these courses in the first year of their BSc.
Okay, doctor, no
Okay.
problem. If you can help us and give us some sample of exams, sample questions, anything, if you can help us for exam,
I
for
can
final exam.
select some examples for you, but you should pay attention that the focus of this course and the exam of this course is on the subjects that I cover in the class. Okay, at first of all, you should continue the class and you should understand all of the slides of the class. Okay, at the next step, you should solve some problems. Okay, keep in
Okay,
mind
doctor.
that.
Can you send this slide to us, please, doctor? Can
Yes,
can you can you give me your email to
yes,
contact with you?
I upload these slides in this site and okay,
Mhm. Okay, doctor. Okay, thank you very much.
I uploaded this reference for you too, this
Okay,
reference
doctor. Thank you.
for you.
Thank you.
Okay, any question?
Doctor, he asked about your slides.
Okay, I said that I uploaded the slides in here,
There is,
courses.aut.ac.ir.
yes, doctor. Yesterday I visit this link. There is only the book, and there is no slides there.
Uh, I will upload